Look at this beautiful piece of engineering. Two straight sections of the highway joined together by a nice, smooth, horizontal curve. But have you ever wondered what it takes for engineers and surveyors to put all this together? What exactly is the geometry behind it? Well, in this video, I'll take you step by step through the calculations that are involved in fixing a highway horizontal curve. But before we get there, let's take a look at the three parameters that are used to fix a horizontal curve. Now, if we take our two straights of the road and we extend them, they would meet at a point called the point of intersection, or PI for short. Now, the beginning of our curve, or BC, is the point where the road begins to part with the first straight line. The end of our curve, or EC, is the point where the road merges again with the second straight line. Now, let's get to the juicy part. All right, so we did see the three most important points in our highway curve. They are the BC, which is the beginning of the curve, the EC, which is the end of the curve, and the PI, which is the point of intersection. Now, first of all, how do we get this PI point? Well, we get it by extending these two straight sections of our highway until they meet at this point of intersection. The angle that they make with each other, which is this angle there, is called the PI angle. In this case, let's call it theta. Now, let's remember also that our curve, the one that I've drawn in red, is part of a circle of some radius. In this case, let's call the radius of that circle r. So therefore, it means that the radius of our curve is also r. Now, the question is, how do we set out these points? How do we fix these 2 points, the BC and the EC? Remember, we fixed the PI by extending these two lines until they cross each other. Now, how do we fix the BC and the EC? Well, first of all, we need to determine this distance here and this distance here. But from circle geometry, we know that when two tangents, which is this line here and that line here, two tangents to a circle, our circle here, intersect at a point, the PI, then the distance from the point of intersection to one of the points of tangency, which is the EC in this case, is also equal to the distance from the point of intersection, the PI, up to the other point of tangency, in this case, which is the BC. So this distance is equal to this distance. But what do we call this distance? It's called the tangent length. So this is the tangent length. Some people call it the tangent distance, but it's the same thing, tangent length. So TL for short. Now, what is TL? What is the tangent distance? Well, it's given by the formula TL is equal to R, which is the radius, multiplied by tan of theta over 2, where theta, of course, is our PI angle. So once we have established our TL, we can set up our machine here. The surveyor sets up his machine here, orientates his machine back along this tangent here. So we set up our machine here, orientated back along this tangent here, and then we measure a distance equal to r tan of theta over 2, where r is our radius. So we do that here. We do the same thing for the EC. Orientate our machine forward along this tangent, measure the distance r tan of theta over 2, then we put our EC. So now we've got our BC and our EC. What next? Remember, the curve is continuous from the BC all the way to the EC. So we need to put a few more points, depending on the length of the curve, a few more points along the curve so that it can be well defined. Right. How do we put those points? Now, supposing we want to put a point Q, which is on the curve. what we do is we set up our machine on the BC. Then we calculate an angle alpha, which we must swing the machine from this line to get to this ray here, this line here, along the chord. Remember, we cannot sight our machine along the red line. It's a curve. We can only sight along a straight line, which is this line here, the chord. So that will get us to the point Q. But the question is, what is this angle? This angle alpha is called the deflection angle, and it's given by deflection angle is equal to 90 multiplied by C divided by pi r. Now, what is C? C is the arc length, this one here. Now, supposing we want to set out a point which is 20 meters from the BC, then our C would be 20. Remember, r is our radius, and pi, of course, is a constant. So let's just repeat that for a minute. What we want to do is we want to set out the point Q. So we are going to measure along this chord here, and we set up our machine here. We orientate it 0 degrees along this line. Then from 0 degrees, we swing an angle equal to alpha, which is this one here. Then it will put us along this chord line here. Now, what about the distance we have to measure from the BC to there? That distance, let's call it x. So what is x? X, the chord length. So chord length or distance is given by r sine of, 2r sine of alpha. So our chord length is given by 2r sine of alpha. So let's go through this again. We put our machine on the BC, we orient it, we set our angle, our horizontal circle to 0 degrees up forward to the PI. So our machine is looking towards the PI and the machine is reading 0 degrees. Then we swing it an angle equal to alpha, the deflection angle. It will take us to this ray here. Once we do that, we then measure a distance x to get to Q. This distance is the chord distance, and it's given by 2r sine of alpha. Let me just write it here. It's equal to 2r sine of alpha. You might have been asking, you're writing r all over the place. Where did you get r from? Well, in my next video, I'm going to discuss how to determine r once you get to site and you want to set your curve. If you enjoy this, please do subscribe, follow, share, and like. Till next video, bye-bye.